Back to my channel, everyone. So today we will be focusing on how to convert from decimal to binary today. The next videos will be focused also from converting from binary to decimal, but that would occur at a different video. So let's get started on how to learn how to go from base 10 to base 2. So the binary numbering system has a radix of 2. It's only two digits. It's either 0 or 1. The computer, it pretty much talks in binary. So it's 1 or 0, on or off, true or false. So how do we convert from base 10 to base 2? So there's two different ways that we can do it. We can either do it by a repeated division of 2 or the sum of weights. So this picture right here is the repeated division of 2. So I'll just walk you through it instead of you really having to understand exactly what's going on in the graph. So we want 37 of base 10, and we want to figure out what's that in base 2. So what we're going to do is we're going to divide this by 2. How many times does 2 go into 37 perfectly? It goes into 37 18 times perfectly, but 18 times 2 is 36. So there is a remaining number of 1. So now we divide 18 by 2. It goes into 9 times. 2 times 9 is 18 perfectly. So there is a 0 remainder. So how about we divide it by 9 by 2? It goes into 9 4 times. But that's 4 times 2 is 8, so there is a remaining value of 1. Now we divide 4 times 2. Goes into twice perfectly, there is no remaining value. 2 times 2 is 4. Then we do the same thing. 2 divide 2. Goes into it once perfectly, so there is no remaining value. Then we divide 1 by 2. It goes into it 0 times. 2 does not go into 1 because 2 is larger. So the last number is this remaining number right here, 1. So the way we read it is we read it going up. So what 37 in base 2 is, I'll write it over here, give it some space. 37 in base 10 is 1 right here, 0 0 going up this way, 1 0 1, base 2. But there's also the sum of weights, and I believe is much easier. So the sum of weights is using powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and 2 to the 6. So we want to figure out how many, what's the highest number that can go into whatever number. We subtract that and keep going on. So what do I mean by it? I'll show you 1 second. Let's just figure out what these powers of 2 are. 8, 16, 32, and 64. So we want to figure out 37. So what's the highest number of these bases that goes into 37 without going over? 64 doesn't, 32 does. So that's 2 of 5. Right? 2 of 5. And now we are left with 5. So what's the next highest number that goes into 5 without going over? 16 doesn't, 8 doesn't, but 4 does. So that's 2 to the second. Alright, and there's one value left. There's 1 left. 2 doesn't go into 1. 1 goes into 1. So it's 2 to the 0. So I'll just go over here to make some space. 2 to the 5 plus 2 to the 2 plus 2 to the 0. So the way that that bits work. We start off at 2 to the 0. Remember, these are bits. It's either 1 or 0, so their power is just 2. So let's say the decimal place is right here. And whatever that we found, whatever of these that we found, we place a 1 at them. So we start off at 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. We can ignore this one because 2 to the 5 is our highest one. So we're going to put 1 there. We're going to put 1 at 2 to the 2. And we're going to put 1 at 2 to the 0. Remember, this is 32 plus 4 plus 1 equals 37. Base 10. Alright, and then this is in binary. We fill the rest of these with zeros. So that was the first time you guys got to look at it. Let's try it one more time for 85. So what I'm going to be doing the sum of weights method. So it's going to be the same thing. Let's figure out what our powers of 2 are. It'll come to the point where you won't even have to remember these. You just know them off the top of your head. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4, 16. 32, 64. So what's the highest value of the power of 2 that goes into 85 without going over? It's 2 to the 6. So we have 2 to the 6 plus, so we subtract 85 minus 64. Right now we are left with 21. Now what goes into 16? What power of 2 goes into 16 without going over? 32 goes over. We are left with 16. So that's 2 to the 4th. Ignore this. So that leaves us with 5. Now what's next? What highest power of 2 goes into 5? 8 doesn't, 4 does. We are left with 1. And this is 2 to the 2. And now 1 is 2 to 0. So there's 7 places. 1, 2, 3, 4, 5, 6, and 7. 2 to the 0. All the way to 2 to the 6. So 2 to the 6 has 1, right? 2 to the 4 has 1. 2 to the 2 has 1. And 2 to the 0 has 1. So it's 2 to the 6. It's 64. 2 to the 4 is 16. 2 to the 2 is 4. And 2 to the 0 is 1. So this is 80. Plus 4 plus 1 is 85. In a decimal. And then binary, it's 1 0 0 1 0 1 in base 2. We're going to do the same thing. So what's the highest power of 2 that goes into 245? We can go to 2 to the 7, 2 to the 8th. It's 156. Oops, I'm sorry, 256. Let me double make sure. Yep. All the way to 2 to the 0 is 1. 1, 2, 4, 8, 16, 32, and 64. So 256 is not going to it properly. 128 does. 64 does. 32 does. So what is that so far? 2 to the 7 plus 2 to the 6 plus 2 to the 5. So 128 plus 64 plus 32. We're at 224 right now with these. That leaves us with 21 so far. So 16, 4, and 1. So what is that? That is plus 2 to the 4, plus 2 to the 2, plus 2 to the 0. So we have 8 places. 1, 2, 3, 4, 5, 6, 7, and 8. So 1 here, 1 here. 2 to the 4, 5, 6, and 7. So 2 to 7. To 4. And the rest are filled with zeros. So that's 245 in binary. So when we have a fraction part in a binary, when we're doing decimals with fractions, we need to separate the integer part and the fraction part. So while we did like the sum of weights method or the repeated division by 2 for the integer part, we're going to split the fraction part and we're going to do a multiplication of 2. So say if the value is 6.875, we're going to multiply by 2. We're going to take whatever number this is, and that's going to be our bit. Then we're going to take this, multiply by 2, take this number, that is our bit, take this number again, multiply by 2, take this bit, take this number, multiply by 2, take this bit, and we keep continuing until it's 0 or that we have enough bits. For example, some decimal numbers can go on forever. So sometimes you can just go on till you do like 3 or 4 bits or until it's 0. It really depends on which fraction you have. Like the next question is going to be fairly simple. So we have our 27, our fraction part, and we have our integer part. So for the sum of weights method, we're going to do the same thing. So it goes up to 32, 16, 8, 4, 2, and 1. We're going to choose 16, 24, 26, and 21. So that's 2 to the 0, plus 2 to the 1, plus 2 to the 3, and plus 2 to the 4. Let's count out 5. 1, 2, 3, 4, and 5. 2 to the 4, 2 to the 3, 2 to the 1, and 2 to the 0. And that is our integer part. Now for this one, we're going to take the fraction part, multiply by 2, figure out what it is. We have one fraction bit, so this is going to be our 1. And since we have 0, we don't continue. So what our answer is 27.5. In binary is 11011.1. So we take that 1, put it right here. So we join them back together. So that's what it is in base of 2. Easy enough. So let's do that one more time. We have 111. We have 0.75. Now let's figure it out. What's the highest one? 64 plus 32. What is that? 96 so far. 96. So we need 15. So we can add 8 plus 4 plus 2 and plus 1. So 12, 15. So what is that? That is 2 to the 6, 2 to the 5, 2 to the 3rd, 2 to the 2nd, 2 to the 1, and 2 to the 0. So let's count out 7 places. 1, 2, 3, 4, 5, 6, and 7. 1, 1, 1, 1, 5, and 6. That is our integer part. Now we do the repeated multiplication for this one. So it's going to be 1.5. We take this digit and we multiply the fraction part again. times 2, 1.0. We take this, and we have 0, so there's nothing left. We read down of our bit digits. Doesn't really matter since they're both 1s. So this is the answer. And for the last question, it's a little bit more difficult, but it's okay. So we separate it. So what we're going to do is, this one's going to be a little bit higher powers. So 1, 2, 4, 6, 8, 16, 32, 64, 128, 256, 512, and 1024. So this fits in. So 1024 plus 128 is 1152 right here. So we can definitely fit in 64, which is 1216. We need about 18. 1234 minus 1216, 18. So 16 fits in and 2 fits in. So what are we looking at? We're looking at 2 to the 1 plus 2 to the 4, 5, 6, 7, 8, 9, and 10. Plus 2 to the 7 plus 2 to the 10. So let's count 11 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 2 to the 10, 2 to the 1, 2, 3, 4, 5, 6, 7. Alright, that is our integer part. 0.98 times 2 is 1.96. Take this one, multiply the fraction part times 2. 1.96 times 2, 1.92. Take this part, same thing. 1.84 times 2 is 1.68. 0.68 times 2, 0.34. 0.34 times 2 equals 0.68. Just read it down. You honestly did not need to do as many bits that I did. You could have like stopped over here. Really depends on the teacher, but for the most part, they usually don't ask for you to do the bits that much. So this is the end of the video, guys. Thank you for watching. If you enjoyed the video and want to hear from me again, be sure to hit that subscribe button, leave a like, and comment below. Have a nice day, guys.